Hi guys, it's Mr. T again, and I'm still hanging out at my virtual beach here and wanting to teach you some more algebra too. Previously, we talked about graphing simple rational functions, okay? And we started off looking at this new parent function and a rational function just simply being a fraction ratio that has an x in the denominator, okay? And we have these things called asymptotes, okay? And why do we have this vertical asymptote? Well, we can't ever use 0 for x. So that's how this vertical asymptote showed up. And then we plugged a whole bunch of numbers in for x, and we saw that it never crosses 0. So we kind of came up with that. But that's a previous thing. We did some simple stuff with that. And then we took it to the next degree and started to say, hey, well, what if we had like um, -2. Well, how about that? -2, like that. And then maybe we had like a +3 on the outside, and how that would change our asymptotes. So we kind of looked at that at the previous video. That's where we're set up. But now we're ready to move up to something a little bit more complicated. Now, this one's a pretty complicated one right here next to it. And we see that it has two denominators, so it could have up to two asymptotes, but it's got this little hole in it. It's got this diagonal asymptote, all kinds of stuff. So what I'm going to do is I'm going to split this up into 3 videos, okay? Um, and the videos are going to be based upon all of the vertical asymptotes are the same, but the horizontal asymptotes have 3 different scenarios. And so we're going to walk through those in just a second here, okay? So here's some of this is on page 401 in our current book in section 8.2. That really doesn't matter, but here's some good examples with some different things that we're going to look at in that sense. Okay, I got it. And now previous talking about those different scenarios. Okay, the vertical asymptote always is that vertical dotted line, that vertical force field is always because you can't, there's certain things that would cause us to have a 0 in denominator that's undefined. We can't divide by 0. And so that's a pretty straightforward thing. And we'll reinforce, I'll go back over that as I go with the examples. But the thing is, how about that horizontal one? That's the one that isn't so straightforward. And so what we have here is 3 different scenarios. And it all comes down to the degree. Okay. So let's first of all figure out something. It says, what is P of X? Okay. Well, the numerator, get this guy out of the way. The numerator is P of X, okay? So that's that guy right there. That's always talking about the numerator, okay? And then it says the denominator is Q of X. So that's this, all right? And we got 3 different scenarios. What if the numerator degree is smaller? What if the numerator and denominator degree are equal? And what if the denominator's degree is bigger? The 3 different scenarios that we have. Okay, I'm going to do 2 in this video that talk about what happens when the degrees are equal. Okay, so what do we mean by degrees? So let's just review that before I go into those examples. Slide down here. Couple of vocabulary words before we go any further, though. Don't forget about here is fancy words. We talked about things called discontinuities. Is when you're moving along the graph and it doesn't continue. Okay, it's some discontinuity. So those asymptotes cause discontinuity, and there's 2 different kinds of discontinuity. There's one of the discontinuities, infinite discontinuity, and that's what those asymptotes do, because it runs up against that asymptote and infinitely doesn't ever cross it, so it never has continuity there. But there is another scenario that's with something called a point of discontinuity. Okay. So instead of just coming up to a wall and running alongside the wall, what they do is it comes up to it, jumps over, and then keeps going. So and that ends up being what's more commonly called to about is a hole. But the official name is point of discontinuity, and that will show up in 2 videos from now, actually, and got an example of that. But let's go back to these degrees, okay? And so here are a few examples, and I don't really care about all this other stuff right here. What I'm mostly watching here is what's the degree, and all of these are in standard form. So we're just going to take the highest exponent of the variable. So you got a variable, its highest exponent. Well, in our first example here, there is no variables in the numerator, so the degree of the numerator is zippo, right? And then the degree of the denominator is 1. So in this case, the denominator has the higher degree. Okay, now looking at another example here. Look at these guys. The degree of the numerator is 1. The degree of the denominator is 2, the highest exponent. So the denominator has the higher degree in that example. Okay, another scenario here. The numerator and denominator have a degree of 1. Okay, so they are now equal. So that's the scenario that we're going to focus on here in just a second. Okay, so then we got another little dude here. And again, you see that 4 in front? Well, that's A, and we'll find out what A and B are in just a moment. But the degree is still the highest exponent. So it's a degree of 1 and degree of 1. 4 doesn't change the degree. So those are equal. Okay. And then last we come back around here to this bottom guy here. And we got a degree of 2 in the numerator, degree of 1 in the denominator, so the degree on top is bigger. So those are examples of when the degree is bigger on the top or bottom, or if they're equal. Okay, so we're going to be focusing on these guys right here for the most part, though. We're going to these guys right there for this first video. That's the scenario that we're going to do a couple examples of. Okay, so let's jump into those. All right, here's our first example here. And the rule says, let me jump back a couple here. This is the rule we're working on. This guy right here. It says when they are equal, our horizontal asymptote, right? The horizontal asymptote is going to be y equals a over b. Where's this a and b coming from? Well, let me show you where that is. In this problem right here, this example here, the number of the in front of the numerator, in this case, is a little thicker here. That's a 1 because it's assumed. And the number in front of the denominator there is 1 as well. So A, B, okay? So it's A over B. So we just take those two guys right there. And so our horizontal asymptote is going to be y equals 1 over 1, which is just 1, okay? And and then what about our vertical asymptote? Okay, well, remember our vertical asymptote is just whatever would make that 0, the 0 of it, right? So if I plugged in a positive one, that would make it division by 0 very bad. So we're not going to allow that. So we got x equals positive 1. So I'm going to come over here. First thing I'm going to do is put in my asymptotes, okay? So here we go. We got x equals 1. So I'm going to put in my asymptotes. My vertical asymptote goes through the x there at 1, and just put it in my asymptotes. Yeah. Now my horizontal is also at 1. Okay, so I got my vertical and horizontal asymptote, kind of my force fields. Now the next thing I'm gonna do, plot points, and a bunch of points, really. You just want to, because this is going to be a strange shape. We need enough points that we know exactly where this thing's supposed to go. So I've already got this into my calculator here. I got the y equals 1 here, and then I got the x plus 3 and x minus 1, and the equal signs are highlighted. So when I go to my graph, I can see that that's what they're going to look like, okay? And the vertical asymptote, you can't see at the moment. It's the one that's going right down in there, because these 83s don't do x equals as easily. So that gives us an idea what we're going to do, and then I'm just going to go second to my table. And mine happened to come up at -9. So I'm going to go back to 10. Okay, I'm going to go all the way back to -10 and go from -10 to +10, and I think it'll give me a good picture. And I'll do a lot of those points. It's just plotting points. It's not that hard. Okay, so that's where I did that and just went to second graph. That's my table, and I'm going to graph several of these. Okay, you notice that this is one all the way down. That's just the horizontal asymptote. We're going to be messing with these guys over here, and a lot of them are really close. So, all right, but I'm going to have to take this down so you can see me doing the graphs. Okay, but I got my handy dandy calculator here, and I'm going to grab those same points off of here. And if you want to follow along with your handy dandy calculator, seems like a good idea. All right, let's get to plotting some points here. Okay. So I got -10, -0.6. So -10, oh, +0.6. About there, as best I can do. And then -9.6. Okay, just a little bit over half. Let's jump over to -7, which is exactly half. -5, that's 1/3, 0.3 repeating. -3, that's 0. See, I'm doing not every point, but I'm doing all the points that just help me keep my pattern. So about -2, because I bet you it's about to turn. Yes, it is. Go -1/3. It's -0.3 repeating. -1, -1. 0, -3. And then I get to 1 error. Why did I get 1 error? Because that's the asymptote. Okay, so I just plotted points. Connect the dot. Connect the dots. And I don't have much going on here. So I'm going to kind of mirror the other side as it continues to get close, but never crossing that asymptote. Okay, never touching it. All right, let's do the other side. Keep on rolling here. I got 2, 5 over 2 up 5. 3, 3. 4, 2.5. 2.3, excuse me. 5, 2. 6, 1.8. 7, 1.6. 8, 1.5. Well, actually 1.57. 9, 1.5, actually, exactly. And I'm going to go ahead and do 10 while we're out here, and that's 1.4. I think I got enough to get the idea going here. So I'm going to kind of start here. Connect the dots. And head towards my asymptote. There we go. So we got our vertical asymptote, a horizontal asymptote, and then started plotting points. How many points? A whole bunch of them till the picture looks just right, and several will be better than not enough here. So there's one example. Let's do another example when the degrees are equal. So here's another one. So the degree of the numerator is 2, the degree of the denominator is 2, so they are equal degrees. Okay, and it says when our equal degrees, we're going to have to take the number in front here, the 2, and then the number in front here, 1. So my horizontal asymptote is going to be y equals 2 over 1, also known as 2. Okay, then what about a vertical asymptote, though? Well, we really need to know what our factors are, so we're going to have to factor out our denominator. So let's see, what would the factors be of that? Two things that multiply to give me -6, add to give me -1, so that's going to be x and a 3 and x and a 2. So let's get our signs right. We need a -3 and a +2. I think that'll work. All right. So if this is the denominator factored, what would cause division by 0? Well, I think +3 and -3, those would be the zeros, right? So we want to avoid them. So our vertical asymptotes would be x equals 3 and x equals -2. So I come over here to x equals 3 and dot, 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 dot. So we got 2 vertical asymptotes with this guy, don't we? That's okay. I could use my line tool, but this is kind of how you're probably going to see it anyway. So -2, here we go, this kind of deal. How about, and then the horizontal is going to be y equals 2. I'll tell you what, I'm going to impress you and use my little fancy drawing tool. Put my arrows on the ends of it and everything. It says 2. So come up here to 2. And isn't that nifty? Yeah, don't always want to show off, you see. There's the deal with that guy. So there's our vertical and horizontal asymptotes. We showed where they came from. What do we do now? We go graph the thing. Plot points. That's how you graph. Okay, so here we go. And so this time I go to my calculator and I have already got the information in. However, I do not have, see, I think that's supposed to be a 2 in this case, right? The y equals. And then over here, oh, I got it typed in already. So let's turn this one off. Hit enter, turn that off, and then come down here. I've already got it typed, and so I hit enter, and see, and it'll highlight that dude, see? And now we can go take a look. All right, so there's the deal. Kind of funny looking. And then again, you got that vertical asymptote going there, vertical asymptote going here. Plot points, guys. Just plot points. It's going to get more interesting in the next couple of videos, but that's okay. You just go plotting points. And again, I got to change screens so that, but I'm going to be doing the same thing here and using my handy dandy calculator that I have here in hand. Again, I'm going to start at -10. I want a good feel for this thing. So at -10, I'm going to go up to 2 and almost 2.3. So 2 and 1/3 basically. And then, okay, still some more thing. And then we got -8, 2.4. Okay, actually going up just a little bit, isn't it? And then -6 is 2.75. So it's, yep, it's still heading up. -5 is actually over 3, just a hair. It's on 3.08, and then 3.7, and then -3, +6, way up here. Okay, and then we don't get another one because that's where the asymptote takes over. So I'm going to kind of go this way, connect the dot, and then come up this way, gently heading towards that guy. Okay, just plotting points, It's not that hard. Then I'm going to jump down here to our next section and plot some points. Okay, because again, -2 has an error. So -1, -3.5. -1, 1, 2, 3.5. Bam. And then 0, 1.5. And then 1, -1 1/3. And then 2, -2.75. Okay, and then there you get the asymptotes. So I'm going to kind of move that along there. Gentle. And come along here. Now, I don't know if that's actually the top piece, the maximum of that spot, but I could calculate it. But for our purposes, this is good enough. All right, jumping over that asymptote, going on to our next one here. Okay, picking up at 4. Okay, so over 4, up 4.8, nearly 5. Okay, and then 5, 3.1. So 2, 3, just barely over. And then 6, 2.6. Okay, 8, 2.26. 8, 2.26. Now I'm going to jump down to 10 here and get 2.1. Over 10 up to 2.1. So you can see it's getting down to the hugging stage seriously right there, isn't it? Then keep on sliding up. Okay, that's rational graphing rationals with a little bit more complicated, not just the simple situation. And these two examples that I've just done are when the degrees are equal. Okay, hope that's helpful. Come on back and I'll show you how to do it when the denominator degree is bigger.